Alright, so we're going to do problem number 26, and it states a couple is traveling by car on a straight highway at 40 kilometers per hour. They see an accident in the distance, so the driver applies the brakes, and in 5 seconds the car uniformly slows down to rest. And so we are asked a couple questions. The direction of the acceleration vector is in the same direction, opposite direction, or 90 degrees relative to the velocity vector, and then we're asked to explain why. And then lastly, we are asked by how much must the velocity change in each second from the start of braking to have the car completely stop. So the first answer is the acceleration is in the opposite direction, or is it in the same direction? So or is it 90 degrees to the direction of the velocity vector? So I drew a picture of the car going down the street, and we're trying to figure out which way the acceleration is going. Well, if I accelerate in the same direction of the velocity or the motion of the car will speed up. But the car doesn't speed up, it slows down according to the story problem. So because the velocity is a vector and we're heading one way and the acceleration is a vector, it's either going to increase the velocity or it's going to decrease the velocity. And so if it's to decrease the velocity, it wouldn't be going in the same direction. Okay? Now, when we talk about vectors, what we're essentially saying is that we're going to think of like a number line. Usually going to the right is in the positive direction and going to the left is in the negative direction. And so it probably is going to go in the opposite direction because we want to decrease the speed. It's not going to be 90 degrees relative to the path of the car because then it would cause the car to turn. So the acceleration has to go in the exact opposite direction. That means that it would be a negative acceleration. So we're going to do some math and use an equation, but when we're done, we should expect to see a negative number. That's what causes the car to slow down. Now, when we get into two-dimensional kinematics, we'll talk more about the mathematics behind vectors and things of that nature. But just for now, conceptually, it makes sense. If the car is traveling forward, the acceleration has to go in the opposite direction to cause the car to slow down. And mathematically, what that means is that if we have a positive velocity going forward, then we would have to have a negative acceleration. So now let's list our variables. We're given that the initial velocity is 40 kilometers per hour, the final velocity is 0 meters per second, and then the time is 5 seconds, and then we're asked to find the acceleration, which we expect to be negative. The only issue really that we have to do first is that our initial velocity is in kilometers per hour, so we've got to convert the kilometers per hour to meters per second for the math to work out. So we've got 0 meters per second on one side. The shortcut to find 40 kilometers per hour is to take 40 and multiply it by 1,000 because there's 1,000 meters in a kilometer, and then divide that by 3,600 seconds. So if I say 40,000 meters divided by 3,600 seconds, that comes to 11.11 meters per second. So 40 kilometers per hour is actually 11.11 meters per second. Then I plug in the time of 5 seconds. So now I have a bunch of numbers in the variable a. I just go through algebraically solving. I'm going to subtract 11 from both sides. And then that leaves me with 5 seconds. I'm going to divide both sides by 5 seconds. And when I plug my 5 seconds in, I'm going to end up with negative 11.11 divided by 5, and then as you can see I have meters per second. So that gives me negative 2.2 meters per second squared. So everything worked out. My acceleration is in the opposite direction of the velocity. It's negative 2.2 meters per second squared.